right. Mr. Colby uses the same password for everything. True story. It is 5 letters. Maybe that's true. Maybe it's not true. None of the letters repeat. None of the letters repeat. Oh, that's important. And they are all taken from Colby Math. Oh, interesting. If you try to crack this password, please don't do that, and make no mistakes, what is the most tries you would need to make? So in other words, if you try every possible password, how many tries will that be? Alright, let me see. None of the letters repeat. Do we have any repeated letters anyway? These are all distinct letters, I think. There's no other C, there's no other O or L or B or Y. No, these are all different letters. That makes the problem a little bit easier. But is it a permutation or a combination, or is it maybe some other type of problem? It feels like the fundamental counting principle to me at first, but I believe it's also a permutation. I mean, certainly not a combination. The order does matter. The order of the letters in the password does certainly matter. So I think it's both a permutation and an application of the fundamental counting principle, because I'm leaning more towards fundamental counting principle. So let's talk about that first, but I'll also show you that it's a permutation after that. I'm selecting 5 letters. So my first choice, how many choices do I have? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 different letters in Colby Math. So I have 9 choices for my first letter. My second letter, because none of the letters repeat, I've already used one of them, will be 8 choices. And we know from the fundamental counting principle we'll be multiplying those choices. For the third letter, I would have 7 choices, and then 6, and then 5. And that would be my 5-letter password. Let's do that. 72 times 210. I believe it's 15,120. I'll glance at my key. Alright. This is also a permutation of 9 letters selected 5 at a time. Because if I do 9 factorial over 9 minus 5 factorial, that's 9 factorial over 4 factorial. And when you expand the 9 times 8 times 7 times 6 times 5 times 4 factorial over 4 factorial, and the 4 factorials cancel, you see that it's the same thing we get. So permutations are just applying the fundamental counting principle, as are combinations, but with that extra divisor of r factorial to account for the order not mattering, and to keep you from double or triple or quadruple counting the same arrangement. All right, 15,120. I'm going to go backwards, see if I find it at the top. 50, there it is, F.